Ma'am, kindly restrict sharing their displays. Someone has shared their screen.
Pungudi ma'am, Ningas.
Good afternoon, sir. So you're muted. Your voice is not audible, sir.
What's going on? Yeah, it's audible now?
Yes, sir. Now it is.
Sorry, so as I said, I'm traveling from Prayagraj, so I'm on a cab.
Okay, sir, okay.
So I'll keep my video off. I'll keep it on audio.
Okay, sir. So, madam, just now she texted that she's wrapping up her office work just now, it seems. So she would be joining soon.
I'm joined as well.
Yes, ma'am. Welcome, ma'am.
Hello.
Welcome, ma'am.
Hi.
Hi, ma'am. Good evening, ma'am.
Good evening, ma'am.
Good afternoon, everyone. I'm really grateful to each and every one of you for being here with us today. We, the Department of Computer Science and Information Technology, proudly organizes Virtual Tech Talk on blockchain technology. Now I would like to call our principal ma'am for welcome speech.
Ma'am, kindly share the YouTube streaming also because a lot of participants are waiting, it seems. Yes, ma'am. It's my great privilege to invite all the participants to this program, and it's a honor to us to have such a session organized by Dr. Rakesh Agarwal, who is a very renowned person, academician, and at present sir is supporting as consultant in various academic-based activities, and because of him only we are getting such reputed speakers like Madam Tamil Shelvi from Kuala Lumpur. We are really pleased to have you here, sir and ma'am. Though sir is traveling, he is supporting us in all aspects, and madam, she has joined. Let me introduce a few about madam with a few words about her. Madam Tamil Shelvi, having 15 years of experience in international banks, serving across corporate and retail banking, specialized in payments, risk management, financial crime, and compliance. She has varied experience in managing business solutions, leading product management, and driving project delivery in these critical areas. She has engaged in transformational initiatives in cutting-edge payment solutions and regulatory initiatives, serving across regions globally. Madam is presently working in Standard Chartered Bank, Kuala Lumpur. We welcome you, ma'am, and really I and my team as Michael Job Institutions, we are really proud to have you among us. And for the participants' sake, let me introduce Michael Job Institutions. Michael Job College of Arts and Science is a part of group of institution called Michael Job's Center with a school and a B.Ed college. And Arts and Science College has 13 undergraduate program and 7 postgraduate program and 1 research program. It is affiliated to Bardiyar University, and as of now we are working on various new programs like especially about entrepreneurial based activities and our students are doing all their projects related to industries. We call it as academia industry venture. Mainly Standard Chartered Bank members are the mentors of our students. So through that we started experiencing all these very good TED Talk contents. One such program is we are doing. Thank you all. We welcome. I welcome you all once again. Thank you.
Thank you, ma'am. Before we plug into the agenda, I would like to extend a warm and heartfelt welcome to our distinguished guest, Ms. Tamil Chelvi, Standard Chartered Bank, Vice President of Project Risk Malaysia. We welcome you, ma'am.
Thank you so much.
Your presentation.
Can we start?
Yes, ma'am.
Yes, ma'am. Yes.
Okay. Thank you. Thank you for the warm welcome. Thank you, ma'am, and welcome to this session. So let's just start with a simple question. How do we know we can trust somebody? Maybe it's a friend, or you've known for years, or it's a big corporate companies like banks as assistants says that you can trust them. You just imagine, a world where trust is not built on any contracts or banks or intermediaries, but just purely on mathematics and code. A world where a farmer in a remote village can sell their produce directly to a buyer across the globe, without even stepping into the bank. You just imagine such a solution. So this is not a science fiction, and it's happening today, and that's the magic of blockchain. So good evening, everybody. This is Tamil Selvi from Stanchart Bank, and this evening I'll be engaging you on blockchain technology, and we'll be giving you some insights on this technology and how it is actually revolutionizing across industries. Since I'm from banking industry, my most of the use cases would be on the banking area, but we will also be taking some time through to other industries where it is touching lives and also the industries and how it is creating impact in our economies and people's lives. Yeah, just a quick check. Am I audible? And the systems are okay, right?
Yes, ma'am.
Okay, thank you. Okay, sorry about that. Okay, let's just start off with some simple use case. Hope you all have the habit of going to the library where you will borrow storybooks, right? So you just imagine the storybook like a digital book. Okay, so where we borrow a book and then we will make an entry in the library, right? But here there is a twist. This particular copy is just not maintained by one librarian, but then whomever wanted to have a copy, it is just being shared among everyone. Okay, so if anybody wanted to have a copy of it, then they need to have an agreement with everybody in that particular network, and only then an entry can be made. So here the entry means it can be of any event or it can be of any transaction. Okay, and that particular process we usually call it as consensus in blockchain. Okay, so just let's imagine this particular situation and see how blockchain is actually playing a role. So each and every event here is actually grouped into a block. And this block is like, just imagine a page in that particular storybook. So once this particular block is full of events, it is then sealed and connected to the previous page. Page is nothing but a block. So it is creating a chain of blocks. Can I request to put the chain of blocks slide, please? The previous slide.
Yes.
So it is just creating a chain of blocks, something like this. Okay, so every page I'm referring here is like every transaction that is happening is getting recorded here. So we will get into the details of it. Okay, so how is it actually running?
Hello. I am Anisha.
May I request the participants to put yourself on mute, please? Okay. So this particular framework is actually running on a cryptography. It is like a lock and key mechanism. And so we need to ensure, right, whatever data that we input into this particular page is secure and not, not being tampered with anything, correct? So it is all run on a cryptography model. And to keep everything secure, each and every block is actually protected, using a unique digital signature. Okay, that is called hash. And this hash is like your fingerprint. So every fingerprint, as you know, is unique, right? And it cannot be the same. So the hash is something like that. So if anybody, in the network is trying to change the data, it is just not possible, and it will get alerted or either it will get rejected. Okay. And the third thing is the decentralization. The next slide, please. Yeah. So decentralization. So here, not the entire library is just not controlled by one librarian. So whomever is having the copy is acting as a librarian. Okay. So instead of one person controlling this, it is actually shared, and it runs on a decent. So I'm hearing a lot of noise actually. Yeah, thank you. So here, instead of one person controlling this, it is actually in a shared network, and it is not owned by any single entity, but it all acts on a decentralized model. Yeah. And the fourth part is the consensus mechanism, as we've already seen. Even before every block is added to the chain, everyone in the network will have to agree on it, like the library example we have seen. And everyone will have to agree that it is a valid one. So there are various technologies and algorithms are used for this, like proof of work and proof of stake. So it is like a crossword puzzle, right? Probably you all would have done in a newspaper where we all play with the puzzles, right? And we will be able to solve the puzzle only if we put the correct word. Even instead of A, if we put some other letter, or instead of if instead of one single letter, if it gets changed, we will not be able to solve it. The same mechanism applies here, and there are various algorithms that are being used, to do that such validations in that consensus mechanism. So this is high level of what is blockchain. Yeah. So in a nutshell, if you ask me to define what is blockchain, it just runs on a digital ledger technology, and which has revolutionized a lot of businesses and commerce, and it is just actually eliminating the need for any centralized database, any centralized storage, or any centralized control authority like the banks today we have. Yeah. And it actually presents a time-stamped and immutable blocks of data. So this is very important. So the time-stamped and immutable block of data. Immutable means no one can alter this. No one can touch this data. Yeah. And it is not owned by any single entity, but it is actually managed by group of nodes of computer, where each and every block is actually secured and linked using cryptographic principle. Yeah. So the immutable and decentralized nature of blockchain has actually redefined trust, ownership, identity. So if you take the financial systems, it is today providing a secure, fast, transparent, and pseudo-anonymous solutions using these networks. Yeah. So that's the basic definition of blockchain, and we will be discussing various use cases in banking industry, in payments world, and in few other industries. And let's just get into the details of it. So before we get into that, let's see some history. Next slide, please. So probably if you all heard from your lectures or with your parents in 1990s or in the early internet stage, if you ask them what is the killer app, can you guess what is the killer app in those times? Isn't it email? So it was big wonder when one person can send an email to somebody else, right? And today's world, the killer app, we call it as blockchain because of the magic that it is creating in a lot of spaces. Yeah. So let's just see some history. Okay. Sometimes people would have seen cryptocurrency or Bitcoin as blockchain, but actually that's not the case. The introduction of this blockchain technology actually happens by a person called Satoshi Nakamoto in the year 2008, okay, where he has first introduced Bitcoin and he has deployed this blockchain technology. Yeah. And he has actually published a paper on cryptography and finance. So, this paper actually defined Bitcoin as a peer to peer transaction. Peer to peer means person to person transaction in the electronic cash system. And it actually proposed a way, to make any transaction without involving any third party or without relying on any banking system. Okay, so you know what he did on the phone, 3rd January 2009. Satoshi Nakamoto, he mined the first Bitcoin block and it actually rewarded him 50 Bitcoins, and he actually did a transfer as well. His friend, I believe, Hal Finney, he was the first Bitcoin recipient from his friend. Yeah. So, thus, he has actually introduced the concept of blockchain with the introduction of Bitcoin, and that is referred as first generation in blockchain technology, with the introduction of Bitcoin, and which is called as a digital currency. So, which is actually helping to move funds from one party to another without any intermediary. So, what is exactly cryptocurrency? Any guesses? So cryptocurrency is nothing but the digital currency which can be stored and bought and utilized over the blockchain or the distributed network. Okay, so it just works similar to your digital cash. So probably you all would all be using GPay, right? It just works similar to that way. But only thing is, here you will be able to feel the real presence. You all would have, we all in today's world use rupees, right? The actual physical currency note. But cryptocurrency doesn't have any physical presence of it. And it is all handled as a virtual, and it is just nothing but a digital cash which just have no real world presence. Then how do we actually determine the value of the cryptocurrency? We all know the INR, Indian rupees, and when it is compared to USD or any foreign currency, we know the value because of the current market condition. But how is this value of this particular digital currency is actually determined? So it is actually determined based on the market condition and demand and supply. If you all would have ever seen this in the news or in the crypto platform, you would have seen probably after the session, you could compare the Bitcoin rate just 2 years before and today, how it is actually happening, or even within a week, how it is actually fluctuating. Yeah, so it is extremely volatile and it is all determined based on the market conditions and the demand and supply. Okay, so this is how the first digital coin has come into existence in 2009. So this currency you can actually use to trade, and you need not have any centralized authority. Yeah. So what is the advantage? So today we have a bigger banking system which has a robust system in place which makes all the transaction. But what is the difference the blockchain technology is bringing to the table? Because it is cheap and it is transparent and it doesn't have any centralized thing which makes your system so transparent and making things so simpler. Yeah. So on the other note, there is also something called token. Yeah. So token, what is token? It just doesn't have any exclusive blockchain network. For example, you all would have seen Bitcoin or Ethereum. So it all has dedicated network. So not every cryptocurrency will have such network. There are some tokens which can operate on top of the existing network. Yeah. So like a Binance coin. So you all would have seen this in the news or in the crypto platform. So it is the same thing. I'm just giving some name to it as how it is actually being referred in the finance world, and how are we going to link this to the technology. Yeah. Okay. So let's get into some basics. So how do we make a transaction? If we wanted to make any transaction, how do we do it? So in earlier days, we used to issue check deposits, where whomever wanted to issue a check, the check will be issued. Then we will present it in the bank. Bank will collect the check, and the money will actually be updated as a ledger balance. So say 1,000 rupees we have deposited. It wouldn't be possible to go and immediately withdraw the money from ATM. You need to wait for a few days, to make that as available balance. So the money gets updated. Then we had the industry has revolutionized, and we had a lot of new things comes in. We need not get into the bank. You can operate at your home. You can do anything. You can make a transaction, and if you don't have a money, you can use credit card with the credit line available, and you have debit cards and all that stuff, right? So what happens actually when we make a transaction? So you all would have used internet banking or from the bank, right? From one person to another person. Say you wanted to transfer a money, 1,000 rupees. So what is exactly happening at the back end? So it is depending on, to which person or to which city or in which currency you are making the transaction, the days will differ, and also which payment type that we use. So when we all make a payment, you would have seen RTGS, NEFT, and if you choose particular option, the days will vary. Probably if you want to make a USD dollar payment, then it is a different cutoff time, and based on the clearing and settlement, the time will vary, right? So what exactly happens? So there are a lot of intermediaries comes in place, before the transaction reaches the end party. There are a lot of intermediaries actually uh, uh, today playing the role before the transaction is actually transferred. Okay. So just let's imagine, okay, one of you, say Priya. Priya got an admission in a university somewhere in US. Okay. So now she needs to make a payment to her university in US dollar. So how she makes the payment? Her father probably having an account in State Bank of India, and from State Bank of India trying to initiate the payment. Can I request to go to the next slide, please? The next slide. So she is approaching the bank, so probably State Bank of India, and logging into the internet banking, trying to make the payment. So when the payment is actually made, the money is actually getting debited from the INR, and then it is getting credited to US. So will that happen immediately just like that? Will SBI know about, let's say some bank in Bank of New York, some American bank? Do they have any correlation? How will this all happen? So, right? So there are various steps involved in it. So by the time everything gets completed, almost it will take a week's time. But how cryptocurrency or blockchain technology is changing this position? So let us see. Can I request to put the cross-border conventional payment screenshot slide, please? Yeah. Okay. So what is exactly cross-border? So the scenario that we have just discussed is a cross-border where money is traveling borders, right? So from India, we are trying to make a transaction to some country and in some other currency, right? So it is always not straightforward, and you can see how many boxes are there from person A, from the initiator to the end party, right? So if you ask me to define cross-border, it is actually the funds which is sent from entity one country to another recipient in a different country. In this case, State Bank of India from INR to American bank, that is where the Priya's university is holding an account. So they don't have any common ledger in between these two banks, and it involves series of intermediaries as you have just seen, and it all happens through a arrangement called correspondent banking, meaning between State Bank of India and Bank of New York there will be another bank that will get involved. Yeah. So, is it just one bank? No, it again depends on the arrangement between the sender and the receiver's bank. Okay, sometimes it will happen, it'll just be a direct bilateral arrangement, or sometimes it will be more than one bank that will get involved in this case. Yeah. So, how actually it happens is in the correspondent banking arrangement is we have a reciprocal account with each other, which is called as in banking terms nostro and vostro, and there is foreign currency exchange that gets involved. So probably Priya needs to make $1,000. So equivalent to of INR, how much she should pay, she should transfer depends on the FX rate on that particular day. So it incurs lots of FX loss, and again also the amount, what is the volume or value you are going to transfer, that is also one of the criteria in which the time that take place will get decided. Okay, so you just imagine how this situation is going to get changed in the with the help of the blockchain. So in the same scenario, if we assume State Bank of India has actually adopted a cryptocurrency model to clear cross-border transactions, so in that case, the INR money will actually get converted into a digital asset, and then it will be sent to the receiver's bank. Receiver's bank should also have that same technology, and he should be able to receive that in digital asset format, and then again this digital asset gets converted into US dollar payment. How long do you think this particular journey will happen, the entire travel? It all happens in minutes. Whereas in our current model, where we've been seeing it all takes like a week's time, here it all happens in just a minute or so. It doesn't have any FX loss, and it is all transparent, and you will be able to know whether the other end, the receiving end, receive the payment or not. Accurately, you'll be able to see the transaction status. Yeah. So how actually this conversion happens from INR? So the digital asset, when I say there are a lot of stable coins in place like USDC, you have a lot of stable coins, and we also have few specific cryptocurrencies that support such cross-border payments. Let's see those details. Yeah. So again, if we get back to the definition, so initially I have touched upon few high-level concepts, right? So we will be keep referring the same concept, and we will be seeing how those technology gets applied in these every step of it. Okay. So again, let us try to link the definition that we have seen earlier for this particular example that we have just seen. Yeah. Sorry. Okay. So again, blockchain is a form of a distributed ledger technology, and it stores all the committed digital transactions. So here we have seen one example of Priya trying to initiate the INR transaction using a cryptocurrency. So like that, there could be many number of transactions that will get initiated, right? So all those such that earlier in the library example where we have referred as event in a page. Similar to that, a transaction in a block. So every single transaction will get added to that block, and then it gets validated by a network of independent nodes. And once that is added, they need to get validated, and it needs to reach to a consensus agreement, which means the validation will have to be done by the miners, who will be doing the part of the validation. And once all these steps are completed, then this particular transaction will get appended to the blockchain network. Yeah, the chain that you have seen. So only after all these steps are successful, it gets added. Once it is added, that's it. We won't be able to alter anything because the same copy is retained with every other block, every other participant in the same node. So it is not simply possible for us to alter or make any fraudulent or suspicious activity once the particular transaction gets added to the network. Yeah. So thus, as and when the blocks gets created and added after these verification and consensus is all agreed, it is all linked with one another, because each and every time there could be millions of transaction happens globally. So it is all forms a link, and that's the reason it is just creating a chain of link, and the term comes from there as blockchain. So what exactly is the block? Again, if we get into the details of the block, it is nothing but a data. It is like just a container which holds lot of data. What is data? It could be a transaction, which in this case we are seeing all the transaction that we get initiated is a data, right? And that gets stored like a piece of digital information in that particular block. And again, as we have seen, as and when it gets added, it will get stored along with the timestamp. What is timestamp? At what time actually it is getting added. Yeah, along with the cryptographic functions, the lock and key mechanism that we have discussed earlier. So if we just analyze, the structure of the block, how it actually looks like. So it will have a header, the block structure. It will just have a header, and within that you will have list of transactions. It can be one transaction or it can be more than one transaction as well. So this block header actually contains metadata. So it will actually have the hash of the previous block and timestamps. When the particular transaction was created, what is the version, nonce, and the Merkle tree root. So there are few new terms I'll be referring, and we will be discussing this in detail subsequently. Yeah. So how do we actually identify a block? A block is actually identified either the block hash or using the block height. So block hash is the hash ID of the block which is generated, while the block height actually defines the positioning of the block in the blockchain. So I've used the terminology called Merkle tree. What exactly it does? It actually gives the fingerprint. Earlier we've seen in our basic terminologies where the hash is like a fingerprint. Who provides this Merkle tree fingerprint of the entire transactions, that is hash of the block. Say if there are thousands of transactions, will there be thousands of hashes, do you think? No. So say there are thousands of transactions, there will be between transaction 1 to 2 until 1000. For combining 2 to 2, there will be a hash generated. Again, whatever the hash value generated on top of it, until they derive the single hash, the process will get continued. And as it actually gives you a tree structure, that's the reason it is referred as, Merkle tree. So again, the block header contains the field to store this particular hash ID of the previous block in the chain. And if there are any changes, again, it has to be validated by the data miners in the network. Otherwise, we will not add it in the block. Yeah. Okay. So let's assume, so this is the basic term. So let's assume the user is now trying to request, trying to make a new transaction from their wallet application. Like in Priya's case, from SBI using crypto, they have just submitted the particular transaction. So in the blockchain network, what happens after that? It just gets broadcasted. It just gets broadcasted to the network. So once it is broadcasted in the network here, we refer peer-to-peer, the P2P network of computers, which is commonly people will refer it as nodes. Okay. So why do we have to broadcast it? For the next step, that is for the transaction validation. So the transaction, so once Priya's father submits it in the State Bank of India, it is joining the network, it is getting broadcasted in the network. So what and all do you think this particular transaction will contain? When you make a GPay payment, you would have seen, what are the details you would see? Like first, who is sending the money? Say you are sending the money, how much you are sending? Say 1,000 rupees. Whom you are sending? Any references you want to put? Or probably in the net banking, it is the same thing, right? So it will obviously have who's the sender, who's the receiver, what is the amount, what is the currency, what is the value date, etc., etc. So all those forms the information of the particular transaction. So here in the blockchain, apart from all the transaction information, one other thing gets added, that is digital signature. Yeah. So the newly requested transaction or INR in the digital converted currency, once this gets added, what happens next? Who is actually going to do the validation for this? So this particular transaction that gets submitted, it will get added to the pool of other unauthorized transaction. Because here we are talking about the network that is running globally. Like Priya, there could be thousands and millions of people who would have made such transaction. So all those such transactions will get joined in this particular unverified pool of network. Then our data miners will come in place. They will pick up the transaction and will try to do the validation. Okay. So once they have done this, they will mine them and that will get created, a new block will get created once this particular validation gets completed. Okay. So this block actually consists of the selected transaction along with the metadata that we have just earlier discussed, right, associated with the block. So what is the role of the miner? He actually finds the hash output for the block and broadcasts the block with the signature. Yeah. So the other nodes in the network actually verify the signature of the block to establish its validity. Because we back discussed, right? It is a shared data. May I request Vishnu to put yourself on mute, please? Okay. So, yeah. So, can the moderator please turn off the line?
Please, yes, ma'am, kindly mute him. 1 minute. Mute him, ma'am.
Thank you. Okay, so this actually gets added.
Ma'am, remove him.
So Vishnu Ram,
He's
please
not
kindly
muted.
mute you.
Okay, no problem. The line is muted now. No worries. Okay, fine. Are you all with me? Is it boring?
No, ma'am, we are all yours.
Okay, fine. In case, just pause me, stop me if I'm giving too much of information or if it is too fast. Just please interrupt. Let's take a quick break and then we can again start over. Yeah. So where are we? So we were discussing about the data miners, right? So like people who are so passionate doing such jobs, even if any of the engineers who wanted to do that, they will act as a role of a data miner who will be doing the validation. What they will get by doing this, they will get rewarded. Sometimes even the portion of the transaction fee in terms of a gas in Ethereum and all will get added. So we are not getting into that. In case of time permits, we will see it at the end of the session. But for now, we will just pause here on the data miner's role. Yeah, we will do the validation of the transaction. So once the validity is confirmed, a consensus is reached. Consensus is reached, meaning agreement is reached to add the block to the existing blockchain. So every other block that is added on top of the block is considered as the confirmation of the block. Okay, it is like playing a Lego game, right? Probably you all would have seen kids playing. So if we just disturb one, everything will get it just get dismantled. It is something similar to that, and it is just not possible, to just insert things without the validation or consensus of the people on the network. Yeah. So you would have now understood that consensus mechanism, it actually forms the backbone of any blockchain based application. Yeah. So the decentralized nature of the blockchain requires a set of rules to identify the way for the user to agree on a particular state. And this set of rules is provided by the consensus mechanism. So there are a lot of algorithm involved into it. Okay, we are not getting into details of those algorithms, but to name a few, it's like proof of work, which was introduced actually for the Bitcoin network, a Bitcoin blockchain. And after that, there are several such consensus algorithms have been, introduced to address the demands of blockchain application. Okay. So, what are the various types of blockchain? So, before we get into that, we've already seen the definition of blockchain. So, hope you all with me. It is a distributed ledger technology which is running on the cryptographic model based on hash algorithm. Each and when a transaction is created, it needs to get validated, and the consensus will have to get arrived before it is getting added, and it is purely decentralized. Yeah, what is decentralized? We all know what is centralized, right? Like the way our banks are operating. Probably you all would have seen the movie, right? The Lucky Basket, where the same banking scenario would have been discussed, and in one a scene where there will be a dialogue of his particular account getting frozen. So this particular account is held in a particular bank, and the particular bank has the authority over the account to freeze the money if they want to. If they want to freeze the cards, and if they want the users or the customers not to utilize or withdraw the money, they have the power to do so. But he is lucky enough and smart enough where he has withdrawn the money before the freeze is actually applied. So that is centralized, where we are purely relying on the banks and we are trusting them and giving the control over our accounts and deposits of all our money. So that's our current model. Whereas here, decentralized, it is not one institution bound because of the definition itself. As you could see, it is a shared database, and no single organization or a person has a control over it. So it is decentralized and you need not trust anybody. And in fact, the dealings are happening even with anonymous. I mean, parties don't know each other. You need not trust each other because it is all happening based on maths and code. Yeah. Okay. So now let's talk about some architecture piece of it. Yeah. types of blockchain. Any guesses? What are the different types of blockchain? Any guesses? What are the different types of blockchain? See, in any technical thing that we discuss, there is something called ownership, right? Whether it is a public, it is owned by a public, or or it is a shared network, or it is a private. Similarly, in blockchain, the architecture depends on two major aspects. Okay, so how are they actually deciding it? Again, based on the ownership. Okay, ownership of what? Ownership of the data infrastructure, citing whether the blockchain is private or public. And secondly, the permission associated with the joining, read, write, and commit, like in any code that we do, right? Commit operation. So that decides that. So based on these aspects, the blockchain architecture and the solutions are developed for the users. So we have open and closed blockchain. So those are based on the write permission. Okay. While the public and private blockchains are actually based on the read permission. Yeah. So the public and private blockchains are actually defined in terms of who can write the data. Like anybody can write the data. So that's the one factor that determines this. Okay. So considering this read and write permissions, these blockchains, you can further categorize this as open public or closed public, open private, and closed public. Sorry, closed private. Yeah. So any examples that you can quote in real life or in the news, or if any of you had exposure to blockchain, any researches that you would have done, you will be able to relate the real world present networks. Any guesses like what are the public blockchains? So far we've been discussing about Bitcoin, right? So Bitcoin is actually on the public blockchain. Then we have Ethereum that we will be discussing it in a while. So what is public? We all know. It is just open to anybody. And they facilitate the peer-to-peer transaction without any intermediaries. And we have another one, private. Private is permissionless. So it is actually governed by some entities. For example, like State Bank of India, they wanted to implement blockchain technology for their cross-border payments. Will they just go into some public blockchain? Most of the time, no, right? They will validate, they will decide based on, banks has a lot of things like AML, anti-money laundering, regulatory and all that. So they will mostly go with the private blockchain, something like a Ripple network, and because it has some authority over it, right? And those are used by such institutions. Why they do that? Because of enhanced privacy and faster settlement. Okay, so now we just covered the introduction of first generation Bitcoin, the blockchain technology. And we have just discussed the basics of blockchain and how it got introduced and various basic use cases. So this is how, the journey has actually started. Yeah. May I just take a second pause, please? Sorry about that. Okay, so now let's talk about version 2.0, our second generation blockchain, and what it is actually bringing to the table. So the second generation blockchain, if we call it, actually they have come up with a very interesting concept that is called smart contract. Okay, so what is contract in a general definition? What do we mean by contract? Let's say, as a tenant, I wanted I wanted to say now I'm here in KL and I wanted to occupy the particular condo, particular unit in a specific apartment. Can I just get into that unit and pay money, pay rent, and can I reside over there? No. I will sign up an agreement with the owner with the certain conditions to it. Okay, what is the duration I will be staying and what is the rental period. If I fail over because we don't know each other, what if I made any damages when I move out of the house. So all those conditions will be spelled out because there is no trust, probably because we don't know each other, and the house owner will be more concerned whether am I be prompt in paying my rent and all that. So not only this, so in any businesses we take it, right, whether buying or selling a property or in any real world thing, right? So the agreement will comes in place, nothing but the contract comes in place. So what if I can tell you this contract, it all runs on a code, an executable code as agreed between these two parties. Okay? And most of the time they don't know to each other. There is no trust required. No, there is no fear because it is all running on the code, on the max, right? So that's the introduction that happened in the second generation. So the Bitcoin, similar to, Bitcoin in first generation. In the second generation, the major revolution was Ethereum. So that is another network. Okay. So let us just see to that. Okay. So in Bitcoin, you have seen the major use cases of transactions and how it is actually facilitating, especially cross-border payments. So, like, probably a question comes to your mind. Okay, so is this blockchain or crypto, whatever blockchain technology, is only for making transactions, only to transfer a value, transfer a money from one party to another party? No, you can actually transfer anything of a value. Okay, so that we will be discussing it in a while. So with the introduction of smart contract, there were a lot of industrial applications that had come in place. Okay, so what exactly is this Ethereum smart contract? Yeah, they are actually programs or scripts that are deployed and executed on the Ethereum network and which can be used, for example, to make a transaction. If there are certain conditions 1, 2, 3, 4, 5 met, then it is executed on the network. That's it. Yeah. Okay. So again, this is an open source and developer can utilize this technology to create any decentralized application. Okay, and that is called as DApps, decentralized applications. So what exactly the difference between Bitcoin and Ethereum? I have already spelled out. Any guesses what exactly you think a difference could be? The introduction of smart contracts. So Ethereum actually allowing the developer to host any new apps on its blockchain with the help of smart contracts and dApps. So you can do a lot of automation here. So that is the big catch in the Ethereum network. Yeah. And it is solving a lot of problems that Bitcoin couldn't do it. So a person called Vitalik who has developed it, and he actually has tried to see things in a different perspective. Again, consensus algorithm, proof of work initially. However, they do have plans to move over to other stuff like proof of stake algorithms. Yeah. So again, to spell out the differences, Ethereum belongs to second generation blockchain technology, which mostly works on the smart contract, whereas Bitcoin doesn't have that option and it purely works on transferring the money. That's it. Yeah. So again, to reiterate, what is smart contract? It is similar to a legal contract. Whenever we buy a property, you would have all seen in your households, right? There will be a lot of patrons and legal documents. where it is all documented and the conditions would be agreed between both the parties. So smart contract is similar to that, but it is written in the code and it is signed prior hand by two parties using it to perform a task such as transactions. Yeah. And it can be used to exchange assets, including properties. Okay. And it actually automates ownerships and copyrights and also automate the organization. So there are few terms like DAOs and there are a lot of things. So when I say copyrights, even in art world, if people had done any artwork or music work, so these things can be utilized over there, implemented over there as well. So again, the smart contract work without any centralized authority, and it takes the advantage of automating the task. So the contract is held between two anonymous parties. They don't know each other, where events are triggered, and the code is actually executed. Yeah. So basically here in our particular finance example, smart contracts can be utilized automatically to release the money when there are certain conditions actually met. Yeah. Can you please leave the slides of blockchain or probably in the screen, please?
Yes, ma'am.
Okay. So a smart contract can automatically release funds once certain conditions are actually met, as we've just seen. So as a developer, you can develop decentralized dApps and it aims to solve a lot of problems and it actually facilitates the service over Ethereum network. So it has actually grown a lot since its introduction. Yeah. So we have seen the major differences between these two, Bitcoin and Ethereum. Again, to put it in a basic terms, Bitcoin actually was created as an alternative to our native currencies like Indian rupee or USD dollar. Okay. So it actually tried to act as a medium of exchange and a store of value, which means tomorrow imagine like instead of rupees, you're carrying Bitcoin to buy something. So that was the initial intention of creation of the Bitcoin. Whereas Ethereum was actually intended as a platform to facilitate immutable and programmatic contracts. What is immutable again? Without altering any data, it is actually trying to execute on the programmatic contracts and the applications via global virtual machines. Okay, and thus it is actually taking the position as the infrastructure. So that's the main intent of Ethereum. And there are a lot of wonders and magics that had been done using these things. Probably after the session, there are a lot of free sites where you can try your hands on all these things, and you can make a test transaction, how particular transfer can be done, and what is the back-end technology that is being used, and all that you can try your hands actually on all these things. Yeah. Okay. So the another network is so similar to that. Since we are discussing about the payments, we will take yet another example of Ripple network. Yeah, it is yet another network which focuses major focus was on cross-border payments. So it was introduced for that. So the currency of Ripple network was XRP. Okay. So the backend technology for cross-border crypto again involves, as we've seen, the combination of blockchain, cryptography, and the distribution computing, and also here APIs as well. So it all works together to facilitate a secure, fast, and cost-effective transfer. Yeah. So there are so as you have seen, right, like Ethereum is a network and the coin is Ether. Similarly, Ripple is a network and XRP is the actual currency. So if you just try to log into any crypto platform, you will be able to see those currencies. So hope you are not getting confused between the network and the currency, right? Okay. So what exactly the Ripple Net does is it is a blockchain-based payment network. It connects the banks and the financial institutions. Yeah. And let's talk about liquidity here a bit. What is liquidity? Assume, probably you would have heard it in your household. Okay, so tomorrow I wanted to withdraw from the bank, say 1 lakh rupee. Can I just walk into the bank and request the manager, okay, I wanted to withdraw 1 lakh, please give me the money immediately? So because it's a high, 1 lakh is just an example. So it depends on the branch. Probably let's assume it's a very small branch in some remote village and you want it immediately. You're just walking into the branch and asking for the money. Please give me, I want it. Will they give it to you? Will they give it to you? No, ma'am. Money is not available because you should have given the intimation prior hand. Because ours is a small branch, we don't have the liquid cash available with us. Money has to travel from somewhere else. You should have given to us some notification, right? So that's the actual scenario happens if we try to withdraw the real cash, high volume, high value money, from the branches. So what happens exactly in such network? So say Priya is making a very big bulk transfer and using over XRP network. Will there be any liquidity problem because they need to convert it, assume in a digital XRP currency? No, they have an on-demand liquidity solution, so which allows the institution to convert your local fiat currencies to XRP and then transfer the value globally anywhere. You name it, they will do it. And it all happens in seconds. I'm sorry, yeah. I'm sorry, I'm getting distracted. Okay. So, this combination of technologies actually forms the backbone of cross-border cryptocurrency, which provides speed, efficiency, and transparency compared to our traditional methods. Okay, so we have seen definition of the XRP and all. So how exactly it happens? Let's assume some bank in the USD wanted to send $1,000 to a recipient in India. Probably Priya has already joined the college and I assume she actually won some prize money and the bank wanted to send the money and credit it to her father's account. The money is traveling from USD to India, $1,000. Let's see how it's happening in the Ripple blockchain. So the US bank converts the $1,000 into XRP, that is Ripple cryptocurrency, and the XRP is then sent through blockchain to the Priya's Bank, State Bank of India. But both the banks should be on the Ripple network. Only if they support, they will be able to receive it. Once SBI receives the XRP, they will then credit that to Priya's account. Then they will have an agreement whether they wanted to receive it in Priya's wallet as an XRP itself or wanted to convert it into INR, or she may decide, oh no, I will keep the money in XRP only. Maybe XRP value, it's like a stock. If you guys have experienced a stock market, if you got any gift stocks from your parent or a relative, what will you do? Will you be just selling it immediately on the day you got it? No, right? In case if you have the confidence over the company stock, you will wait. You will keep that for a long term. Similarly, Priya may decide, okay, XRP might grow, so I will keep this and then do the conversion. Just for your information, folks, this is just a session on technology. We are not getting into any investment aspects, and it is not any investment related or advices that we are discussing in this session, purely technology related. But if you want to try your hands, but please read through all the risk involved in these things, and also even when you try the technologies. Yeah. Okay. In this scenario, what happens? The money has actually, instead of days, it actually receives instantly. Okay. So let's take another example. So this is blockchain powered payments. Okay. There is no one simple answer or one simple way to make the transactions. Okay. Like I have given you an example, US bank converting into XRP and then it is coming to the wallet as XRP to INR. Is this the only way that I have to do it? No, there are a lot of various other ways, like the way we operate it today. You can use Google Pay, you can use Hippo Pay, you can use net banking. It is similar to that, but that's a different modes again. But here I'm talking about the different currencies or different networks. Okay, that is actually operating in this model. Yeah. So let us take some example of blockchain powered payments. So is the flow okay? Are you all with me?
Yes, ma'am.
Is it too boring content?
No, ma'am. Carry on, please.
Thank you. Okay. Do we have any freelancers out here? Do we have probably in a platform like Upwork or something where you take projects and do it serve globally or within India? Have you ever tried your hands? Let's assume one of you, say Mary. Mary has actually got a freelancing project in Upwork site, and her client is based out of Canada. Okay, and she has delivered some important project and they agreed on a term for her delivery of work. The client in Canada is saying, no, I'm not going to pay you either in your local currency, that is INR, nor in my currency, in Canadian dollar. I am going to make the payment in crypto, like assume some coin, some stable coin, USDC. Okay, it's a cryptocurrency. Okay, so I will pay you in cryptocurrency. So let's see what happens here. So the client actually converts the $1,000 Canadian money to the USD on a crypto platform. So we have a lot of platforms to do all that things. Okay, you can do a paper kind of trading to learn the technologies and see what are the terms that we have discussed. You can just give your hands and see how exactly it is working. Okay, so this USDC is actually getting transferred via blockchain to Maria's digital wallet in India. Okay, so what exactly happens here? What is the technology that is behind it? Based on all the terms that we have discussed, when such crypto payment from Canadian dollar, which is got converted as a cryptocurrency USDC, when it gets credited to Maria's wallet as crypto, how do you think it all would have happened? What is the technology behind this? How did the client would have sent the money? Here comes the public and private key. Okay, so the client's wallet uses a private key. It is a secret code to sign the transaction. And the girl sitting here who has delivered the work, she has the public key address and which is visible on the blockchain. So the public key ensures only she receives the payment, anybody else, because she is the one who delivered the project, right? And then the validation happens. So earlier we have discussed, right, as and when the transaction gets submitted in the network, what will happen? The transaction will get submitted into the network for validation. The same thing will happen here. And the nodes verify the transaction using cryptographic algorithm. So once it's verified, the transaction is then grouped into a block. What happens then? Consensus mechanism. So why we need to do that? To prevent any fraudulent activity, and the nodes agree on the validity of the block. So what are the consensus algorithm we've seen, like example, proof of stake or proof of work. Yeah. Okay, so now the transaction is actually recorded. So the block containing her payment is now added to the blockchain. Now the transaction is immutable. Nobody can alter it because it has already got added to it, right? And the payment is actually received in her account, in her wallet. It all happens within minutes. So now her wallet holds the USDC equivalent to $1,000. So she can decide what she wanted to do, whether she wanted to keep it or converted it into her local currency or whatever. That's her decision. Yeah. So let's discuss some more detail about the new term that we called it here, public and private key. It's like your email and password. If you just take an analogy, just like an email box. So you will have an email ID, and obviously we will only issue our email ID as a contact ID to everybody, right? And whatever email that we get it, how do we open the email? How do we access our email account? By using the password. So it is something similar to that. Public key is like your email address and private key is your password. So that's the analogy. So public key is actually a cryptographic code. Yeah. And that is openly shared with others, and it is derived from the private key and using cryptographic algorithm. And it acts as a unique identifier, and that is used to receive any transactions or data on the blockchain. So anybody can actually use the public key. That is, anybody can use your email ID to receive it, right? To send an email to you, right? Similar to that, anybody can see or use this public key to send the data or verify the signature. So actually, Bitcoin cryptocurrencies, the public key is actually used to generate the public address, which is nothing but your wallet address for receiving the money. Yeah. So next, private key. So the private key is a secret cryptographic code. Again, secret cryptographic code. It is only known to the owner. Password is only known to you, right? You won't be sharing it with anybody else, isn't it? Same case here. So it is actually essential and it's important for signing any transaction. Okay, so what is the purpose? It actually proves the ownership of the blockchain asset and grant access to them. So the private key signs the transaction to ensure they are authentic and authorized by the rightful owner. And it always have to be kept so confidential, right? And in case if it is lost, that's it. Yeah, we won't be able to access any of our digital asset. It is like losing our key. Probably in password scenario, you have a reset option, but here, no, we are not supposed to lose that, yeah. And so if we look at the example, when a user again sends the cryptocurrency, the private key actually creates a digital signature to authorize the transaction. So how it actually works together? Probably you all would be knowing it, right? The key pair generation. So a user generates a pair of key, a private key, and its corresponding public key. And it actually helps in the transaction authorization. So private key is used to sign the transaction to create the digital signature. And how is it actually being verified? Mathematically verified by using the public key without exposing the private key. So once it is done, the network participants use the public key to validate the digital signature, ensuring it is authentic. So in the above example that we've just seen, what happens? The client's private key generates a digital signature for the transaction. Who does the verification? The nodes verify the signature using the public key, ensuring the sender is authentic. So actually these concepts, right, they are so fundamental to our blockchain technology, because this is one of the core thing enabling a secure transaction and data sharing in the decentralized environment. And they all work together as a part of asymmetric cryptography, ensuring security, privacy, and authentication. So asymmetric cryptography. So you all would have heard of symmetric and asymmetric. So here we actually uses asymmetric cryptography. You might later Google it out and explore more what exactly it is and this is a very high level that I've just elaborated. So here I'm just trying to, correlate between the real life use case with the technology and how it is linking together, right? So each and every term that I spell out, probably you can make a note of it and you can get into the details of it to know what it is and technically what is meant, and what are the other things that I have to learn to enhance my knowledge or enrich my knowledge on that particular area, right? So we will be only touching things. We won't be getting into so details of those technologies. Yeah. So no central authority again controls this, and all transaction details are visible to the network and ensuring transparency. So now again, so in the same case about the freelancing project, okay, let's link the smart contract terminology that we have seen earlier. So like as and when she completes the project, does the client need to make the payment? Is it have to be a manual every time? Probably 2 weeks after 15 days she is delivering something and client has to send a payment. After 15 days again she is delivering something else and so is that have to be manual? No. They can agree on a terms, okay? If I deliver, say, module 1, you make the payment of $500. If I complete module 2, probably 50% of it, I'm giving in, say, another 30 days of 2 months' time. So once I deliver that and you're comfortable with the delivery of my work, then the milestone is verified, you can release the payment. So they can agree on these terms and put that and embed that into the code, and rest will be taken care by your maths and code in the form of smart contract, as we've discussed earlier. Hope you'll be able to link how is it actually applied. Your technology is actually getting applied in the real life scenario. Yeah. So based on these self-executing smart contract and based on the agreement between the both the parties, the contract will get automatically executed and the money will get released to the provider. Here, the person who delivers the project. Yeah. Okay, so let's imagine another example. Let's say Bank A. Bank A also uses the same Ripple net to send international payments. So here we have seen actually earlier the client is using the what network the client was actually using to send the money to the freelancer. What currency they were using it? USDC, right? So here let's assume the client is on a Ripple net. What is Ripple net's currency? XRP. So that if the client is actually uses a Ripple net, they can also use XRP as well. Okay. So here XRP actually acts as a bridge currency, converting Canadian dollar to XRP and then to the Indian currency or whatever the intended final money, it all gets converted in seconds. Yeah. So you can see, right, are you able to link through concepts? Like there is no one straightforward way. There are various ways in which the same thing can be achieved. So all need is the freelancer needs to get paid. So how the client wanted to pay using the blockchain, there are various ways. He can make the payment in various modes within cryptocurrency. Like it can be in the direct fiat currencies, or it can be in the XRP in case if the client has the Ripple network, they can do that. Yeah. Again, why this matters? Speed, cost efficiency, security, and financial inclusion. What is financial inclusion? Even if the freelancer doesn't have a bank account, as long as she has the wallet, she'll be able to receive this money. It doesn't matter, right? So even the unbanked population, without even stepping into the bank, we are now delivering projects across markets, and it makes the blockchain concept making things simpler and faster, right?
Yes, ma'am.
So, yeah. Okay, so we talked about liquidity a bit earlier. So, again, when we touch upon liquidity, we also have on demand liquidity and we also have decentralized finance. This is another new term I'm spelling it now. Decentralized finance, DeFi, probably all would have heard of it, and it actually provides liquidity for smooth currency conversion, and even it is actually used for various other purposes. Yeah, we will discuss that in a while. Okay, so now kind of we discussed a lot of important concepts, and now let's explore few other things like blockchain, backend process, and all that we've seen. So how is it actually marrying to other technologies that we have today in place? The one very interesting thing, we all use it every day in all our websites and your banking platforms is API, right? Application Programming Interface. So without API, you won't be able to see your balance. So as long as you log into your net banking, if you want to see your balance, you're able to see it. How are we able to see it? Because there is an API, and the API will make a call in the backend to the backend database, which has the balance information. It procures the balance information, populates it in the front end to you. It all happens by connecting. The API makes a call to the DB and then information gets populated. So in the same way, API can also work together with blockchain technology. So let's see some details around that area. Yeah. Okay. So what is API? So hope you all have an idea, right? What is an API? It is a set of protocols or tools and definitions that allow different software applications to communicate with each other. So why is it, what is the actual intention of using API? Because as I have just explained, it is connecting to the external system or an application. It can be of anything like a wallet, exchange, or apps and all that. And it allows the users and developer to access the blockchain data like transaction history. You can interact with your smart contract. You can create or query in the transaction. You can monitor any network event activity. So it is actually sort of providing a front end mechanism, right? Let's see some example like how they work together, API and blockchain. Okay, so similar to the example that we've seen, your net banking, balance information is fetched from the backend, but it is all governed by the bank. The same concept applies for the blockchain. So when API, it enables the application to fetch and display the blockchain data to users in a very user-friendly manner. Okay, for example, it can show the transaction detail from Bitcoin's blockchain network. Okay, and the APIs can also allow applications to interact with the blockchain for creating and sending the transaction. Like, for example, a payment gateway, which uses API to send funds via blockchain network. So again, as I've said, smart contract execution, monitoring, and all that. So are you able to link the concepts? If you are a front-end API enthusiast, probably you will be able to connect and see things, in what are the real-world problems that we can use your technology to solve it, right? So what are the other various ways practically this can be used? We can fetch the real-time cryptocurrency price from the blockchain. So you just take a Google, probably a CoinDCX platform, just log into CoinDCX or any other platform for that matter, and just try to see what is today's Bitcoin rate. Immediately it will show you the rate. How is it showing? It is connecting to the respective blockchain network and populating the information. So that's how the technology gets connected. and allowing the user to send, receive money, account balance, population. So for all that, it is actually used. Yeah. So, in a nutshell, again, blockchain actually provides you the infrastructure for a secure and decentralized data recording. Okay, while API, it is actually serving as a tool to interact with the infrastructure, making it accessible to the applications and for the users. So together, both API and blockchain, they actually enable a very seamless integration for blockchain functionalities into various systems and services. Yeah? Are you all with me? Boring? Interesting?
Yes, ma'am, we are all with you.
Let me take a few.
Do you share any questions, ma'am? Do you ask any questions?
Yes, ma'am.
Yes, ma'am.
Sorry, but I just a water.
I think ma'am has been completed.
Yeah, sorry, I just took a pause to have water. Yeah. Okay. Coming back. So far we've been discussing the payments, payment solutions and all that. Just imagine, probably I think I have seen 78 people in one room, right? One conference room. Assume all 78 people are trying to make a payment from the same bank A. So all has an account in bank A, and everybody is trying to make a payment now at this moment, and everybody is making a very high value transaction. Okay, and similarly, the same bank A is also serving a lot of corporate clients. Assume it's a salary day. Say a lot of corporate entities are having it. Similarly, it is also serving some LIC kind of insurance provider, and it is also on the same day. Okay, let's assume it's at end of month. Okay, so it is all happening on that particular day, end of month, that particular day. You just imagine how our technology and our payment system will behave. So when we design any system, we will consider all these factors, right? Whether we are a front-end developer or a back-end developer, we will think about all of these things. When the performances, we will think about it. When there are concurrent users tries to access the system, as a front-end developer, I will have to ensure the system should not go down. At the same time, when 79 people plus salary payment from LIC payment, everything hits on the same day, I need to ensure my system is scalable. I should be able to process the payment. In case it then gets queued up, then all the corporates and 79 of you will call up your customer care. Oh my God, money is debited, but my Benny, the receiver hasn't received. What happened? They also needs to answer the questions of 79 plus 100 other customers. So we will also have to think about all these aspects, right? So do we have an answer for these scenarios in blockchain? Yes, we do have. There is something called off-chain scaling solution. Okay, so this is actually to handle high transaction volume off-chain solutions to improve the scalability. Yeah, may I ask how do we have? Are we closer to the end of the session? How long we have? I think 6 o'clock. It's ending. Is it? May I ask the time, please?
Ma'am, here time is 3:20. Actually, we have planned till 3:30, ma'am.
Okay.
10 more minutes.
10 more minutes.
If you want to extend, we'll go another 15 minutes.
Okay, fine. Thank you. Thank you. Then let me accordingly go on with my session. Okay. So it is all done. Okay. So what if the regulatory doesn't approve all of this? So today in India, if we have to implement this, we need to have the regulatory approval for all these things, to get implemented. right? So just because we have invented something super fancy doesn't mean that all our regulations will approve that solution. So whatever that gets designed, it has to adhere to the regulatory nature, and especially in banking sector, whenever such cross-border transaction happens, it needs to be ensured that anti-money laundering, they know your customer. As and when we open a bank account, they'll verify our data. So all those things will have to be taken into consideration even here. Yeah. Okay, so that's about it. And let me quickly touch upon DeFi, which I have touched earlier. So DeFi is a decentralized finance application which is actually using for lending and borrowing. Okay, assume we have a Ethereum currency and we don't want to sell, and we can use that, and with that as a collateral you can do the lending as well. Okay, so it actually facilitates lending and borrowing. So you may Google it out later, and the user, whoever has, can also get interest rate. And again, the technology behind this is blockchain, smart contracts, and yet another technology that comes in place here is Chainlink. Chainlink is another cryptocurrency powered by Oracle technology. If you have any Oracle enthusiast, you would have, interested to know how data is actually getting sourced into this network. So we have something called Chainlink for that, which provides the real-time data to calculate any collateral value and liquidation threshold and all that. So you can explore that as well. Yeah. So there are a lot of apps. So if you put it DeFi apps, we have a lot of DeFi apps available. So as I have already seen, not already discussed, it's not only in banking industry, it is actually helping in a lot of other industries. Like for example, healthcare industry. If you take healthcare, it is like today we all hold our medical records in papers, but with the help of blockchain, it all can be digitized and the doctors can access the data real time and anywhere. And also, similar to API plus blockchain, you can also do IoT plus Internet of Things to blockchain. The wearable devices, right? Like to monitor blood pressure, sugar level. Again, blockchain can be utilized. How about farming, agriculture? Like in case the farmer wanted to export goods, it is possible with the blockchain technology. And in case if they wanted to certify their products or organic products, it can be done. And it can also be utilized in supply chain. So probably you're buying some shoes, okay, and you wanted to know where the raw materials are sourced for that shoe. Is it like made in a proper working condition? You wanted to see the end to end, where and all, from where it got traveled before it reaches your hand. With a simple QR scanning, you will be able to do that. So that is possible. And there is also something called peer-to-peer energy lending. Okay, assume you have solar panel installed in your farm. Tomorrow you have an excess energy, electricity, and you wanted to lend it to your neighbors, and that is possible with the blockchain network. So what is the situation in India? Any idea, like where are we in the blockchain journey? So already State Bank of India, ICICI have already started implementing these technologies for cross-border, and even in government sector, they've started looking into this technology. I believe Maharashtra, they've already started implementing this for land dealings. So real estate is another big sector. So throughout the lecture, throughout the session, you would have heard the term no intermediary, no intermediary. So you would have heard in your household whenever they buy a property or whenever they buy any new home, they'll be worried about whom are we buying, are they reliable, and you have to undergo a lot of agents and brokers, and we have to pay a lot of fees. And obviously, we should also know whatever property that we are buying is legitimate. There is no issue in the legal document, and we haven't bought somebody else. We haven't invested something in a forgery one. So, how blockchain can solve all this problem? So blockchain is actually getting introduced in these sectors to ensure it is all on the network, no intermediary, direct party to party dealing. So Maharashtra has already implemented this, and slowly I believe it will come up in other states as well. Okay. So that's how it is actually playing a big role in all of the industries. So how do you all think that this will help us, in improving our economy? Why do we need all of that? Anyway, today we have a proved system that is in place running for decades. But what is the difference it's making apart from, making things faster and avoiding intermediaries and all? What exactly it is bringing to the table? If you again think through and connecting this to the economy, the real life problem that we face today, because of the so-called intermediaries, the corruptions in the systems, it is actually going to reduce all of that because of direct party to party dealing in all the sectors that we've just seen, from land registry to farming. Yeah. So I think a lot of advertisements you have seen, farm to table and all that, because farmer, whatever he produces and whatever money the first middleman as a profit they are getting it, until as a receiving end in some country somewhere when they get the consume the particular product. If you can see a lot of intermediaries, but at the end of the day, what is the money farmer is getting is it's in peanuts and it's not that great, right? So it's all going to solve this problem, and it is going to connect people, between who wanted the particular product or who wanted the buyer and the seller. It is actually going to connect this, and thus going to also empower the entrepreneurs. So if any of you have any interesting idea and you wanted to have a startup but you don't have startup money, so in that case, even blockchain is actually going to help us to connect with the investors without going through the ventures and all that. Yeah. But let's just not romanticize it here. What will it take for us to be there? It requires a lot of energy. Okay. Lot of energy in the sense, in terms of the data miners role and all that. So the lot of high end computers will have to be utilized, which consume almost a small country, almost equivalent to the electricity that we can supply to a small country. Okay, so even few countries even had banned it for eco reasons. So that is another disadvantage. So that's the reason data mining role cannot be played by anybody, in case if we wanted to. Okay, but even when internet has started, we had such problems. We had a flunky kind of systems, but this will get improvised and we will find answers to that as well, because it is just more than a technology, just like a philosophy, because we are shifting from a centralized controlled environment to a decentralized empowerment scenario. Okay, so it is going to make the industry is more efficient, and I believe all the future generation and all the leaders out here, the engineers out here, will contribute to that and will make this even more better and bring the fourth generation, right, the fourth generation, by bringing in artificial intelligence and blockchain even better place. Okay, so as let me end this lecture by saying the futurist William, what he says is that the future is already here, but only thing is it just not evenly distributed. So blockchain might just be another technology to change that. Okay. Thank you, everybody, and I wish you all very good success in all your future endeavors.
Thank you, ma'am.
Girls, if you have any queries,
Thank you, ma'am.
participants, if you want to interact, kindly come out with your queries. Madam would answer your queries. Ma'am, actually, it's a very detailed presentation. So we all felt it's very convenient to understand.
Thank you.
Basic you started and you have presented with.
Thank you. Because I don't have an idea of the target audience, so I kind of started off with the layman term to slowly introduce the tech concepts. And also, it's not face to face. Hope nobody has left, right?
Feedback link would be posted in the WhatsApp group as well, so that you can submit your feedbacks in that. Ma'am, we would send you the report of feedback to you so that you could understand the response of audiences.
Okay, thank you very much. Thank you very much.
Ma'am, HODCS, what are plans?
Yes, ma'am. Yes, ma'am.
As
Good
we,
evening.
draw to,
Yes.
as we draw to close on this wonderful event, I would like to call Ms. Muthalakshmi ma'am for word of thanks.
Yes, good evening, everyone. I'm honored to give the vote of thanks for today's session on blockchain technology. Thank you, Ms. Tamilchelvi, for sharing your expertise with us. Your insight on cryptocurrency and blockchains were valuable and inspiring. We are also grateful to Dr. Rakesh Agarwal for joining us today. Your presence made this event special. Thank you to our principal, Dr. Shalini Bhagyam Kamala, for supporting this program. I appreciate the active participants for all attendees and the organizing team's efforts is making this event success. Let us use the knowledge we gained today. We make positive impact. Thank you all. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you so much.
you.
Thank you once again.
Thank you. Thank you.